We have to find inverse Laplace transform of this function, which is having one linear factor and another factor is quadratic. So what is it? We start by using the rule of partial fraction. What the rule says, if you have this term, then for linear term it is same, a over s plus 1, plus when you have quadratic term and it's not possible to make linear factors of this term, then we have two constants b and c, and s is multiplied with one of the term. Then as usual we will work with taking the LCM. So it is s plus 1, s square plus 1. To check if it is correct or not, it should be same as in the question. So yes, it is. Now we look for the terms with a and to be multiplied with bs plus c. Okay. So as I explained before, to get those terms, we multiply both a over s plus 1 and bs plus c over s square plus 1 with the denominator s square plus 1. So here you can see that when you multiply it with a, this s plus 1 get cancelled. So you will have here s plus 1. When you multiply with b, s square plus 1 get cancelled. So you left here with s plus 1. Okay, now here small key point, because if you do not follow that thing, you will get stuck and you will end up with a very complicated term. See, s plus 1 is multiplied with bs plus c, but if you are writing it in this way, it shows that c is only multiplied with s plus 1. So for that, it is important to put a bracket in bs plus c. Okay, now the remaining steps are same. Compare the numerator, a times s plus 1 plus bs plus c times s plus 1. We did some mistake in a. Yeah, it should be s square plus 1. S square plus 1. Okay, so let's proceed. Now here we have three constants a, b and c. So it means we need to substitute three different values of s. So let's take the values from there. S plus 1 equal to 0. This gives you s is equal to minus 1. Okay. Now in this case you can see that left hand side is constant. So you are not going to replace s there. You are going to change the value of s here with a, with b and here s plus 1 at these three positions. Here, here and here. Be careful while substituting the values. So this gives you 3 equal a times minus 1 power 2 plus 1 plus b times minus 1 plus c minus 1 plus 1. So see, we substituted s here with b and here. So minus 1 plus 1 becomes 0, and 0, this term is 0, this term is multiplied with b and c. So this entire term cancel to 0. Minus 1 power 2 give you positive 1. So this gives you 3 is equal to a into 1 plus 1. So this implies that 3 equal to 2 times a, which gives you value of a as 3 over 2. Then we need two more values of s. So if we work with this term s square plus 1, if we put s square plus 1 equal to 0, what we can see? S square is equal to minus 1. So s square is iota square, which is an imaginary number. It gives you s is equal to plus minus iota. And we don't want to use the complex numbers because it will increase the complexity. So in this case, as we are not getting any real number from the denominator, we select two values of s on our own. Like in the previous case, we took only one value of s ourselves. Here we will take two different values. So again, you can select any number, but for me I want to keep my calculation easy. I will select 0 because it's not used earlier, and then I will go for 1 because again 1 is not used earlier. If 1 is used earlier, I will go for 2 and so on. Okay, so let's see what will happen when you replace s by 0. Left hand side again it will be 3 because it's a constant, equal a times 0 square plus 1, b times 0 plus c, and 0 plus 1. So here you have to see that b times 0, this term becomes 0. C is non-zero. Okay. 3 equal 0 square plus 1 gives you just 1, which is, so it gives you a. 0 plus 1 gives you 1. So a plus c. Now we already have value of a, substitute it here. So this will give me 3 by 2 plus c is equal to 3. That implies c is 3 minus 3 over 2. So when you simplify it, it gives you 3 over 2. So you will be having c as 3 over 2. You can even use calculator to get the value as 1.5. Similarly, now replace s by 1 in the same equation. It gives you 3 equal a times 1 square plus 1, b times 1 plus c, 1 plus 1. So when you work on it, 1 power 2 is 1 plus 1. 2a plus b plus c times 2. Now this 2 get multiplied inside with both b and c. So this gives you 2 times a plus 2 times b plus 2 times c, which is 3. Now the value of a and c available here, 3 by 2, 3 over 2. Substitute. 3 equal 2 times a is 3 over 2 plus 2b, 2 times c is again 3 over 2. We can cancel this 2 with 2, this 2 with 2, which on further simplification gives you 3 is equal 3 plus 2b plus 3. So we can cancel 3 and 3 on this side. So this gives you 2b plus 3 equal to 0. That gives you 2b is equal to minus 3. This b is equal to minus 3 over 2. Here if I select any other value other than 0, so what will happen? Say let's assume I will select 2. So what will happen in this equation? If I am using s is equal to 2 here, it will give me 3 times 3 is equal to 8 times 2 square plus 1, 2b plus c, 1 plus 1. So when I simplify it, it will give you 2 times 2, 4 plus 1, 5a plus 2b plus c times 2. Right? I have value of a from here. This gives me 5 into 3 by 2. This 2 multiplied inside, 4b plus 2c is equal to 3. So when I solve it, you can see that I am getting an equation in b and c, not directly the value of c. On the other hand, when I used s is equal to 0, I got directly value of c. So my calculation become much easier. That's the reason I opted for 0 instead of any other value. If there is no choice like that, then you have to come up with such things like you have the equation in 4b in b and c, one equation, you have another equation in b and c, solve them and work with it. So now we have the values of a, b and c. Let's write it down. A is 3 over 2, b is minus 3 over 2 and c is 3 over 2. Wow, we got all same values, huh? Okay, so let's substitute it here in the very first place where we introduced a, b and c. So we will write 3 over s plus 1 s square plus 1 is equal to a, which is 3 over 2, divide s plus 1, plus b is minus 3 by 2, s plus c is 3 over 2, divide s square plus 1. Okay, now we need to find Laplace inverse. So apply Laplace inverse on both sides. So what we will get? We will get Laplace inverse of 3 over s plus 1 s square plus 1. It's same as finding Laplace inverse of first term. So 3 by 2 is a constant, take it outside. Laplace inverse of 1 over s plus 1 plus Laplace inverse of minus 3 by 2 s plus 3 by 2 divide s square plus 1. Okay, now we need to see how to work with this. For first term we know that it is e power minus t. Now second term we have two different terms in plus. Okay, so we have to split it into two terms. One term is minus 3 by 2 s over s square plus 1. Second term is 3 by 2 over s square plus 1. In between the sign is plus. So when you work with this, it is same as minus 3 by 2 s over s square plus 1. And this gives you, taking the constant outside, 1 over s square plus 1. Now if you look at the rules in the table, this is minus 3 by 2, cos a is 1, so cos of t. This will give you 3 by 2 sine of t. In between the sign is plus. So we compile the final answer. So this will give you, we have to start from here, 3 by 2 e power minus t. In between the sign is plus, plus, and here minus, so it becomes minus 3 over 2 cosine of t plus 3 over 2 sine of t. This completes the solution.